Hi friends, welcome to my channel. Let's have a look at problem 1099 to sum less than key. In this video, we're going to give a treatment using the two-pointer sliding window trick. First, let's look at the statement of the problem. Given an array nums of integers and an integer key, so we want to find the maximum sum of a two sum such that this sum is strictly less than key, if no such pair satisfying this inequality or equation. So we are going to return -1. So here are two examples. In example 2, so the minimum sum of two elements is 10 plus 20, that is 30. 30 is strictly larger than 15, so the output is -1. And in example 1, so the output is 58, so which can be made up using 34 and 24. So this 58 is very near to 60, and it's less than 60, right? So the constraints for this problem are the following. First, the nums list has a length upper bound, which is 100. So this 100 actually is a small number. Due to this constraint, actually we can write a brute force solution using two for loops, but this is not the way we're going to do treatment for this problem. Secondly, the elements in the list nums is bounded below by 1 and bounded above by 1000, and the k is bounded below by 1 and bounded above by 2000. So with that said, we are ready to look at the treatment and the analysis of the problem. So here, as we mentioned, so this problem provides a good use case for practicing the two-pointer sliding window trick. The idea is the following. So for each left index or left pointer L, so we want to find the largest right index R such that nums L plus nums R is less than k. So this way, actually for each left index L fixed, we could find the largest possible sum S containing nums L and satisfy equation star. So after we check for all the L's, we will find the maximal S such that S is less than k. So that's the idea. So here we want to also explain why the two-pointer sliding window work after we do the sort. So actually it's due to the monotonicity we gain after we doing the sort. So here given L, so let R be the largest possible right index such that star holds. Because the num is sorted from smaller to larger, so we have the following relation. In other words, if the left index becomes larger, then the right index becomes smaller or at most equal to the previous state. What does this sentence say? It says that when we iterate L from small to large, so we could use previous state of R and no need to start over again from the right end n-1. So before we write the code, so here is a natural extension. Can we do to sum larger than k with the problem assumption? So we need to some variant of this idea above or the code below. So with that said, we are ready to do the coding. So for the coding, I'm going to split into parts to isolate the logic. First, I'm going to do the sort. So this is actually important to carry out the two-pointer sliding window trick here. So nums sort, I'm going to sort in place. And after we do the sort, actually we can do some preparations for the two-pointer sliding window. First, let's get the length of this nums for convenience. And also we set the result to be -1 according to the problem requirement here. And then we are going to do the two-pointer sliding window method. So two-pointer sliding window. So let's initialize the two pointers first. The two pointer is the correspond to the two ends of indices. And then it's a while loop. While L less than R, then we can get the sum, that is nums L plus nums R. So if this s is larger than or equal to k, in other words, it validates the above equation start here. So we need to shrink r, right, by 1. Otherwise, so s is strictly less than k. In other words, if we fix L, actually we found the largest possible r, such that the sum s is less than k. So in this case, the first thing we do is to update the result state. So it's the maximum of the previous state and the current sum. And then we want to continue the search for the left index. So we are going to increment this L by 1. So with that done, so actually we finished the problem logic. So next is the return. So we need to return the result state. This is actually the full format of solution using two-pointer sliding window. So for now, we can do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, I guess that's about it for this specific problem. So actually, there are a number of problems related to 2 sums and 3 sums, 4 sums, and in general n sums. And we can also consider their variants, like countings of the pairs less than a target, larger than the target, or other variants. So actually, it's good to practice all of them and gain some better understanding for this kind of problems. With that said, I guess that's it for this video. Thank you.